Okay. Okay. So I'm going to be working with the program ImageJ. If you've already gone onto the website or using the browser version, that's fine. So I'm going to open up ImageJ. One second. What did it? It's getting a little organized. Give me 1 second here. Okay. Okay, so ImageJ is just this little toolbar here. And then the first step that you guys will be doing is bringing in your picture or the picture that we've given you, that example TLC plate. You have to open it in. If you're on the browser, you can go into your documents and then click and drag the picture into the area where it asks you to drop it. But for this, I'm going to go into open and then click on the example TLC plate. And so now that is up for us. So that is the step 3 in the instructions of how to do ImageJ. For step 4, we're going to draw a large rectangle. So you'll see on mine here, the rectangle tool is already selected. If it's not, we would select it. And then starting up here at this pencil line marks where where the solvent front is. So when we are running these plates, we stick them in a solvent system. The solvent will travel up the plate. And then this is as far as the solvent front went. And then all the compounds that you spot down here at the very bottom get kind of traveled up with it, but they won't go all the way up. So when I say solvent front, that's kind of what I'm indicating. So I'm going to draw a rectangle around these dots. These are the HDL dots. And so ImageJ is kind of finicky. All of the rectangles that we're drawing today have to be exactly the same width and height. So they have to be the same area, otherwise you get an error message. So the way we do that is we kind of copy and paste them over. But so the reason I'm bringing this up now is because we want to make sure that this initial rectangle is going to fit all of the other lanes we have here. So I might want to make this a little bit wider because I noticed that this dot is a little bit wider and I want to be able to include all of that dot. So I'm going to make it a little bit wider there. And now to kind of lock this rectangle in place, I'm going to click on Analyze, go down to Gels, and select First Lane. And you'll see now a little 1 has popped up. Now to move it over, I'm going to click on that rectangle and then move it on over to get the second lane in place. And again, this second lane is your standard mix. And then to lock that lane in place, I'm going to go to Analyze, Gels, select Next Lane. And now you see a 2 has popped up. And then finally, I'm going to go over, get all of that in there. And again, Analyze, Gels, select Next Lane. So those are our 3 lanes that we have up. So that takes us from step 4 to step 7, I believe, of the instruction sheet. So now that they're all in place, I'm going to go Analyze again, Gels, and then Plot Lanes. So that is step 8. So now what it comes up with are these chromatogram peaks. So this is really similar to something that you would see in chromatography in general. You're going to see something similar to this next week when we do vitamin D analysis. So this lab kind of gives a good view for you guys of how we actually get these HPLC peaks, or chromatogram peaks, sorry. So this is going to show us each one of those dots. So this, let me see if I can try to get both things on. I don't want that there. Get both the picture and the chromatograms so we can see. Okay. So this top, if you did it the same way I did and have your HDL be the first lane, standard be the second lane, and then pellet be the third lane, your HDL sample should be the top chromatogram. And then if we scroll down, we will see that there are, let's see, I can never remember, no, I did it wrong. I can never remember the best way to scroll down. Might just be that. You can see, so this top one here is the HDL, this middle one here is our standard, and then the bottom one here is our pellet. So the standard helps us identify which peaks are in there. You can see here, so this dot here at the very top, this darker one, is going to correspond with this peak here. Can everyone kind of see when I'm like using my cursor but that's what I'm pointing to?
Yes, we can.
Awesome, thank you. Okay, so yeah, so this dot here is going to correspond to this here, and that is going to be your cholesterol esters. So if you look on page 79 in your lab manual, you'll see kind of a mock-up diagram of what the TLC plates look like, and it helps you kind of identify which one's which. So this top dot corresponds to this peak, that's cholesterol esters. This second dot here corresponds to the triacylglycerides, or triacylglycerols. It's going to correspond to this peak here. This dot here is fatty acids. It's corresponding to this peak. And then this dot here is corresponding to the cholesterol, and it's that peak. And then finally, at the very bottom, we have the phospholipids, which did not move at all and are going to correspond to this peak. So the reason why these things are moving up the TLC plate has to do with the polarity of the substance. So the solvent system that we're using in the developing chambers is very nonpolar. And so since it's nonpolar, the substances that are nonpolar, or most nonpolar, are going to move the farthest up. So from that, we can conclude that cholesterol esters are going to be the most nonpolar of all of these substances, and phospholipids are going to be the most polar because they're not going to be carried by the nonpolar solvent at all. It stays right where we spot it on the plate. So with this standard chromatogram, we can also kind of help identify and confirm that this top chromatogram is actually the HDL, because you see right here, there is a peak for fatty acids, because it corresponds with the fatty acid peak in the standard. And there is no fatty acid peak in the pellet. This is what we expect. Do any of you guys know why that is the case? Okay, well, this is something that Dr. Gallagher drives in a lot, and it's that fatty acid is only going to be found in your serum sample unlike a lot of other lipids, it's only carried around in your serum by the protein albumin. So when we took your little microcentrifuge tube of serum and precipitated out some of the I think it's the VLDL and the LDL into the pellet, we're not precipitating any of that albumin out. So since the HDL is still a sample of your serum, basically, it's still going to have that fatty acid peak because it's still attached to the albumin, whereas we're not going to see it in the pellet because there's none of that serum in there, there's none of that albumin in there, therefore the fatty acid is not going to be there. So that's one of the ways we can help kind of confirm that this top chromatogram is indeed the HDL sample. Sometimes, if you remember how we kind of asked you to wick away any of the remaining serum from the pellet at the end with a little Kim wipe, sometimes if you don't do that, you'll still see a fatty acid peak in your pellet because some of that serum is still going to be there and show up in this chromatogram. Okay, so kind of a little background there, but going more into next steps of ImageJ that you guys will find helpful. So this is going to be step 10. So right now, all we have is these nice peaks, but what we really want to do is convert it to area so that we can create those lipid ratios and then compare it to our spectrophotometric lipid ratios. So the way we're going to do that is click on this line tool right here. And then we're going to connect the shoulders of these peaks. So what I mean by shoulders is kind of like this area here where, you know, you can see it maybe a little better over here, but it goes kind of from almost being a little bit flat to all of a sudden it's going up into this peak. So we're connecting those so that we're just isolating the peak. And when I'm doing this, I'm actually going to have my cursor a little bit outside of the chromatogram line and then draw it across so that it intersects this chromatogram line. What can happen if, let's say, you try to get on the line or really close, you actually might not connect it, and then it will mess up. So ImageJ is a little finicky in that way, because if we can kind of zoom in on that, you know, maybe I thought I was getting the line, but you can kind of see here that it's not actually connected. So we got to make sure that we're actually connecting them. Okay, so I'm going to do that for all of them. If I make a mistake like this and I want to redo that line, I can undo it once and get rid of that line. But what can happen, again, with ImageJ, so I'm going to get that line like that, and then I'm going to purposely not get that line there and make that line. And now I'm going to go and draw my second line. What can happen now is if I want to undo this first line that I messed up on, I'm pressing Control-Z over and over, and it's just making that last line that I drew disappear and come back. So once I've drawn a line and then drawn another line, the first line I drew is, you can't go back and fix that unless you, I think the only way we found is to close down the program, start it back up, redraw your rectangles, and then get your chromatograms again. So if that happens, we'll try to work with you to figure out a way, but hopefully we can figure it out. So I'm going to go ahead and get the area for that. You only need to find the areas for each of the compounds for the HDL and for the pellet. You do not need to find it for the standards. Likewise, later I'll talk a little bit about the RF value, but you won't need to find the RF value for the pellet or the HDL. You're only going to be finding the RF value for the standards. So once I have all these lines in place and they're to my satisfaction, I'm going to click on this little wand tool here. So that is step 11. in the walkthrough. And then I'm going to just click inside the area of this peak. And then it comes up with a number. That is the densitometry value that you'll record into your lab manual. It's telling you what the area of this peak is. This number, it doesn't really have any meaning outside of this chromatogram. That's why we're doing the ratio. That's how we can actually give it some meaning and some value. Because if I say that my cholesterol ester had an area of 33,000, that doesn't really mean anything to anyone. So I'll do that and record, and then I'll show you what happens if I miss this line here. You'll see that the whole area under these peaks got selected. So that area is not accurate. It doesn't show what the area under this little peak would have actually been. It's going to give me a really huge area for this whole thing. So that's why we want to try to avoid that. So then I would go through and collect the areas for all of those. And then you'll do that again for the example pellet chromatogram, finding the areas for each of those. Okay, I think that is it for the stuff with ImageJ. If you have any questions, we'll try to help you out with that. When you're done with this, you don't need to save any of these chromatograms. You can just click out. You don't need to save these. You just make sure that you've recorded them in your lab manual. The only picture that you're going to include for your lab report is going to be this original example TLC plate without the rectangles on it. So that's the only image that you'll include with your lab report. Really quickly, I'm going to go over how to do RF. It's kind of hard to describe virtually because I can't really show you with a ruler here. But oh, maybe I can use my whiteboard, or maybe not. I'm just going to do my best here. So like I was saying, RF is it's a ratio of how far the compound in your standard traveled up the TLC plate over the amount that the solvent traveled up the plate. So for this, let me see. I'm gonna try this. So if I had a ruler here and you could see it, what I would do is measure from this dot here up to the solvent line here. And let's say that distance, I'm just going to make up an arbitrary number. That distance between those two is 13 centimeters. Then what I would want to do is measure from, let's see here, this dot again to the center of this dot. I didn't really do a great job, but imagine that is actually the center. And then let's say that distance from there to there is 12 centimeters. Then what we would do, we would say the RF value for this dot that I measured, the cholesterol ester, is going to be 12 divided by 13. I don't have what that is easily without looking it up, but you're going to give your answer in decimal units, not this fraction. So it would be something like 0.9 something. So that's what you're going to do to find RF. And then you're going to do it again for, let's see here, do blue. We'll do it for the triglycerides. And then that might be something like 0.7. The reason why we're doing this, why RF is important, is that if I took that same standard, but I didn't know what those compounds were, I could actually compare it to an RF value of a known compound. As long as I'm using the same solvent system, the same thing that's traveling up the plate, I can compare this cholesterol ester, this cholesterol ester RF value to an RF value for cholesterol ester that is known under the same solvent system, and then with some amount of certainty be able to say, oh, I think that this is cholesterol ester. For this lab, we give you, we identify those spots for you, but kind of in the real world, if you're working in a laboratory, that's a way that RF could be used. Okay, so that kind of ends what I have to go through for you guys. If you have any questions now or later, let me know. I know it's kind of wonky doing virtual lab, but thank you all for bearing with us.